Now I would like to invite Erol Karacabeyli to deliver his speech.
Thank you very much. Can you hear me?
Yes.
Well? Okay.
Yes.
Thank you. Good day, ladies and gentlemen. Greetings from Vancouver, British Columbia, Canada, to all international colleagues, to my friends in my motherland, Turkey. Thank you for inviting me to take part in this Congress. Turkey has been building its capacity actually to do its own renaissance, to bring its wood culture back, because Turkey one time had a very rich wood culture. So I'm very pleased to take part in those activities. First, I would like to acknowledge this work that I am presenting you is part of a larger project at PFInnovations, expanding wood use towards 2025. That particular year is the year that the next edition of the National Building Code in Canada is expected to be published. And we have quite a few stakeholders, and as you can see, this project actually gathering a lot of organizations to be able to deliver impactful results. I will start with why Renaissance? Why the rebirth? Why should it come back, the wood structures? And I will, get into drivers, attributes, must-haves, where it is happening. Then I will move on to engineered wood products, innovative connection systems. They make the building systems, actually, and I will talk about them. I will touch on regulatory acceptance, which is the codes and standards framework. Move on to prefabrication and multidisciplinary approach. Now, before I start my presentation, I listened to 2 presentations yesterday by Dr. Jakub Sandak and Dr. Callum Hill. And I hear from Professor Cenk Demirkır that these presentations will be shared. And I highly recommend, if you haven't listened to their presentations, they are almost so complementary to my presentation, probably Professor Cekoti's presentation, which will be done next. So these 4 of them all together gives you a much better picture, sometimes in detail. So why Renaissance? Over a century ago in Canada, brick and timber buildings as high as 9 stories were built. The building on the right-hand corner on the bottom is a 9-story building. The facade is brick, and inside is all heavy timber, big beams and big columns. That building is 115 years old. Yesterday, Dr. Hill was saying we should get buildings to last longer. And that building is gonna last probably another century, easy. And it has been nicely seismically upgraded in 1980s, and and then those buildings, by the way, they are getting very high-end companies renting them, leasing them, and there are hundreds of them throughout Canada and US. In the 20th century, on the other hand, the concrete buildings took over, and since then, that is that trend is continuing. Now, with the advent of engineered wood products, I am calling them EWP in my presentation, by the way, and systems, and the push for sustainable construction, sustainable cities. Mass timber is having a comeback in the 21st century. In the meanwhile, when I get into the light frame buildings were always there. Now, what are the drivers? Well, one driver is basically housing needs are increasing because we are having more people on our planet, and people are moving to the cities. So the cities are getting bigger. So that's one driver. And the other one is climate change is a big issue. Actually, our generation has a big task to tackle that. And if we don't, actually, we are putting the future generations in danger. And finally, because of this, we have to build sustainable cities. We cannot continue the way we are doing right now. There is no end to it. Now I'm going to move on to attributes, because what attributes makes wood construction appealing from these perspectives? First of all, you can have faster, cleaner, and quieter projects. And I will get into that with the prefabrication and how that is possible. The second point is, which is very nicely covered by Dr. Hill yesterday, is renewable and carbon sequestering. The third point, it will be discussed by Professor Cecotti after me, is wood structures are naturally resistant against earthquakes because of their lightweight and the way they behave in earthquakes. And this has been demonstrated for centuries. For example, after each earthquake, when we look at even in Turkey, very old structures, if they are not decayed, they do very well in earthquakes. The aesthetics and health benefits, Dr. Sandak touched on them yesterday. It's very important points. And finally, versatile to repurpose. The buildings that I showed you in my first slide, the heavy timber buildings, actually, when they were done first, on the beginning of 20th century or the end of 19th century, they were industrial buildings, but they are now offices. They were repurposed. So what are the must-haves for sustainable wood construction? And this is very important in the sense that if you don't have sustainable forestry and sustainable manufacturing procedures, it is impossible to make the case. Well, that's not enough. You have to have a wood culture where you have wood manufacturing, designers, contractors, and the whole infrastructure. Some countries have them, some countries don't, but it has to be built. When you have these two ingredients, then you can talk about sustainable buildings. The building on the side here, this is Brock Commons student residence in Turkey, not in Turkey, in Vancouver, British Columbia. And that's an 18-story building. I will talk about that building a number of times in my presentation. So where wood-based building systems are gaining more traction? Basically, in the developed world. Canada, US, Europe, Japan, Australia, and New Zealand. That also talks quite a bit about where things are going, isn't it? Now I'm moving into engineered wood products, innovative connection systems. And then I will talk about the wood building systems and separating them into two categories, light wood frame and mass timber. Actually, and also hybrid, because that's the kind of mixing wood systems with steel, concrete, and masonry. I'm starting engineered wood products with lumber. It's either visually or machine graded. And then the next thing is panels. and that's either plywood or OSB, oriented strand board. Now, wood I-joists since 1970s, basically using lumber and panels and some engineered wood products, it's just an I-beam, and you can see that. And they have been in use a lot, particularly in light frame wood construction. Wood trusses is a very old concept, but again, there are quite a few developments in that area. More than 80% of roofs in North America are made with wood trusses, and they are 100% prefabricated. And there are programs, engineering programs, structural engineering programs, and basically the companies, truss manufacturers take the drawings, architectural drawings, and then ask you where is the building. They take their snow loads and other loads, and then they design the building, they design the trusses roof, and deliver to the site. Glued laminated timber is just taking lumber pieces and putting them on top of each other, and then that's a much older product, and it has been in use for a long time. Structural composite lumber. It's a kind of a family products. You might heard LVL, like laminated veneer lumber, PSL, LSL, OSL. They are all in the same family. And they have been in use in construction, both in light frame and in mass timber. Cross-laminated timber, I will dwell on this a little bit because this product actually in practice came from Europe, originated in US 100 years ago, but they didn't pursue with it. And that product is now considered a game changer in mass timber construction. It is, you can produce them up to 60 centimeter thick slabs, which are 3 meter wide and maybe some 10 meter length. And that is, I will show you some examples on that. Similar products, dowel laminated timber, which is using hardwood dowels to connect the laminations, and the nail laminated timber, which is using nails to connect the laminations. Those products are also available now for the designers. The nail laminated timber, again, goes back to 100 years back. And then some of those buildings I showed you, mass timber buildings, use that product. The next item is the connections, because when you have the wood components, you need to connect them together to make a building. And then that's very important. A building system is composed of connections and those components. Again, in the last couple of decades, there are huge improvements and new products came to the market. They are all available now, and designers who are very familiar with wood design, they are making good use of them. One of them actually is the self-tapping screws. Self-tapping screws is designed such a way that they have a little drill bit. They are designed like a drill bit. So you don't need to pre-drill the wood to put them in. They get their own hole, they drill their own hole, and then that's it. So that's a huge, huge new discovery in wood construction, and it's used a lot in mass timber construction now. Now I'm going to get into the building systems. To make it very simple, we have the light frame, and we have the mass timber. I am separating them into two halves. Basically, mass timber frame, which you can see some columns and beams here, and then mass timber plates, which you can have walls and floors. And the hybrid construction, on the right-hand side, you can see the Brock Commons building. It is relying on two concrete cores as a lateral system. I will come to that again in that building. Now, let me start with light wood frame construction. It goes back to 1800s in North America and other countries. And as its name is light, for example, 2 workers here can lift that wall. And I wouldn't try that with concrete, prefabricated concrete walls. That will definitely hurt your back. And this system is actually the most common system in Canada and the USA for single family buildings. I don't want to give the numbers here, but approximately 90% of the single family buildings are made with light wood frame. So this system was the dominant system in housing throughout 20th century. So we are not having a renaissance here. We are actually having a renaissance in the mass timber side. And these buildings, now in the last decade or so, or a couple of decades, in Canada anyway, we were able to build these buildings, light frame buildings, up to 4 stories because of the code. That was the acceptable solution. And in 2009 in British Columbia, the code people increased that to 6. And since then, that propagated to the different provinces, and now it is accepted nationally. And over 60% of 5- and 6-story apartment buildings in Canada now are built with light wood frame construction. Again, these are not demonstration projects. These are real projects. The developers and the construction people and the designers opted to use wood. This is quite important fact for the world to watch. The Scandinavian countries also using wood, light wood frame a lot in housing, probably in the order of 90% again. And they are also going into the apartment applications as well. Here's an example of a kind of a hybrid podium application from US. In US, they are allowing, they call it 5-on-2, 5 residential apartment building on a 2-story, sometimes commercial and building. So it's 7-story high, and some jurisdictions even go to 8. And actually, you can see on the far behind in that slide, there is a 5-on-3. So this one is quite important. Again, it's a competitive system. It's quite repetitive, and it is used a lot in Canada and US. Now I'm moving on to mass timber. Frames and mass timber plates and hybrids. I will give you some examples. One example is on the left-hand side is the Wood Innovation and Design Center, designed by Michael Green. And this building is actually about 30 meters high. It's about the same height, a little shorter actually, than the building, 9-story building I showed you at the beginning, which was built 115 years ago. So we are getting there. The second building is an 8-story building. This building is built with a system called CREE, C-R-E-E. And I highly recommend you to take a look at their website. And because this system is using concrete and wood together. And basically they were putting the building together at 1 story a day, 8-story in 8 days. The other building here is a 14-story building from Bergen, Norway. And that building is using mass timber braced frame. It's a frame around the building, you can see. Inside that building, they are using light frame modular blocks. And then every 5 story, that building has a concrete story to carry the modular light frame apartment blocks. Few more examples from Canada. Arbora complex, one of the largest complexes in the world, in North America at least, and in Montreal. It's an 8-story, multi-family residential building. The important part in that building is the core is made with CLT. Also on the bottom, the Origin building in Quebec City, Canada. 13-story multi-family residential building. The first story is concrete and 12-story is wood, heavy mass timber. This building is also using a CLT core as part of the lateral system. And the building, the Brock Commons building, which I mentioned before, first they built the concrete cores for elevator shaft and stairwells, and then they built the basically mass timber 17 stories. Again, this building has a first story concrete and the rest of it is wood. There is an analogy here why the first story is concrete. There are many reasons, but you can also look at the reasons partially in very, very old traditional wood buildings in Turkey. Usually the first story is masonry. I'm not going to get into too much detail there because I have quite a few other slides to show. Some engineers, including myself, we think that mass timber can also be used with steel. For instance, in the Brock Commons building, they could have used a steel lateral system. And there are great possibilities, and I just wanted to share this with you. And actually, designers and construction people and developers, they should be open to using different materials for different applications. So the race is on Tallwood buildings in the world. On the left-hand side, we had an 8-story building in Finland in 2008. Then there was buildings in 2009 in a building in London, England, and then 2012, Melbourne, Australia, and then Bergen 14-story building that I showed you. The one that 2017 is the Brock Commons, and then the 18-story building in Norway, again using a braced frame system and some concrete floors this time on the top. And finally, the Ho building in 2019 in Austria. So all these buildings actually using kind of different systems, and some of these systems will start to be repeated in the future probably, and those are the systems will be the winners, but we will see. There are quite a few other projects in the works right now. This is just a small number of them. Now I'm moving on to regulatory acceptance, and this is an interesting topic because codes and standards could be very boring for many people. And on the other hand, regulatory acceptance, in one sense, means market acceptance. So it's a very important topic. And I will move on to prefabrication and multidisciplinary approach. Now, regulatory acceptance, because the way human beings chose that way, because we live in different countries, every country has its own building code. Interesting, isn't it? We could use one code, an international code. There were some attempts to do that, but not successful so far. So everybody has their own code, or construction directives. And there are thousands, if not tens of thousands of committees dealing with it. Under the building codes, we have material design codes. one for wood, one for steel, one for reinforced concrete, and one for masonry, and one for wood. Interestingly, again, every country has their own. And then under this system, the whole system is supported by product and testing standards. The design of wood structures in US and Canada is basically split into two. One is for mostly housing, and in Canada for small buildings. It's very prescriptive, and that's what the house builders, they like. And it's like a recipe, if you will. You will use this type of beams and with this type of dimensions type thing in this span. The large buildings are engineered. The whole architect designs it, structural engineer puts, designs the whole, every aspect of the building. So in that sense, if any country would like to get into regulatory business, I always suggested that, they should look at this aspect. For instance, Turkey can look at using Eurocode 5 for large buildings because, it's because of the proximity. But on the other hand, for housing, they may wish to look at Canadian or US codes for housing. The whole system is supported by product and testing standards. And I would like to make a plea here. And the plea is, I chaired the international community on timber structures for 10 years. And in 2018, with a very nice last meeting in Istanbul, I stopped my appointment there. And this committee is coming up with international product and testing standards. And my plea is, please try to use them, because this is the committee, a dream committee, which all the experts from international arena, they are developing the standards. And Japan is the only country who's making all their standards in line with the ISO, which is the international standards. If one day, if the world decides to move international standards, which is a kind of suggestion from the World Trade Organization, Japan will say, I am already there. It's a good position to be in. I'm moving on to prefabrication. Now, this is very huge for all materials, but particularly wood is making huge strides here. It's light, it's easy to work with, and with the advent of 3D, computer-aided design, building information modeling, structural analysis softwares, and automated manufacturing machinery. Now, wood products, components, assemblies, and even three-dimensional modules that I will show you are possible to be done off-site. And then they are brought to the site, and then you can easily put the building together with very fast and with less waste and very quiet too. I just give you the categories of the prefabricated systems here. First area is categories components, like a truss is a component. And the second category is panelized systems, which is used a lot in Europe and in US, and now in Canada as well. And by the way, in prefabrication, Europe is extremely using these techniques and very successfully. And then the last one is modular volumetric systems, where you basically build a three-dimensional box that you can transport, and then you just take that to the site and then put the building together. And some of them are coming with all the services as well. And the digital tools are playing a big role on this movement. Here's an example of prefabrication with light frame panelized system. The panels comes to the side, and then a crane just put them together. You don't need hundreds of workers to do this because panels are already made. And at the end, you achieve a building. Actually, when you look at this building, you cannot even say it's a wood building, but it's actually a wood building, including its lateral system. Few examples on prefabrication with mass timber, because the light frame is already happening and the mass timber is now going on its way. This is a CLT, cross-laminated timber. By the way, cross-laminated timber is simply taking lumber and cross-laminating it and gluing them together. And you can see that there are holes cut, certain grooves are made. These are all done in the manufacturing plant. This is, again, Brock Commons building. Students are having a beautiful view in Vancouver, British Columbia, in this building. And here it is. This building is actually not using any, the designer of the building did not use any beams. And then we tested this concept in our laboratory, and they were very satisfied with the results. You can see that this is a glue-lam column, and then on top, you have a steel connector. And there is another connector just like that coming from the column from the upper story. And those two get into each other. And what happens is you transfer the vertical load from upper column to the bottom column through the steel connector, so that that CLT slab is not sandwiched there. Because if it does, then it's gonna have some deformations, and when you have an 18-story building, those are gonna be cumulative, and it will affect the building's compatibility with the concrete core there. So this is used in Brock Commons building. Excuse me. And this is another example. This time, this is called balloon framing. So in platform framing, you have one wall at a time in each story. In balloon framing, you can have walls that are more than one story. And this is a CLT wall, more than one story, used in a mass timber building. Now, I am moving into the multidisciplinary approach that we are taking at PFInnovations in the last couple of decades. I'm a structural engineer by profession, and as I get into more and more research, and I realize that, oh, everything we do in structural actually in conflict with the acoustic performance. Acoustic designers are saying, you should make the building very loose. And we say, what do you mean? And it's not possible, and things like that. So the whole building system is a balancing act of different attributes: fire, durability, and others. In that sense, we started doing our research in a multidisciplinary fashion. And we are benefiting, and then we are also disseminating our results in that. And that is, I'm going to talk about our handbooks and guides. This idea kind of ended up with that. And we are doing this together with design and construction community. So we have a group of designers and construction people and authorities having jurisdiction, code people. We are working with them, and that makes it true applied research, in fact. And so I will give you some examples. Now, one of the areas that actually caused people to move away from wood was the fire performance. There were huge fires, for example, in Istanbul. Istanbul had capital of wood buildings one time, believe it or not. And but there were huge fires, and that actually triggered movement from wood to masonry. An earthquake comes in, and then masonry doesn't do well, and then they go back to wood. Even in the centuries, people went back and forth between materials. But now, in fire performance, we have the tremendous amount of knowledge, both in light frame and in mass timber, for designing a building which is going to perform well in fire. There are encapsulation strategies, and there are fire suppression strategies, and products like mass timber, they also have inherent charring capability in fires, which you may not have it, for instance, with steel. Another area, which is a serviceability thing. I don't know if you ever noticed this in airports sometimes. Somebody walks on the floor, and then, it actually annoys people. Again, huge amount of knowledge has been gathered in the last couple of decades on that, and they are being disseminated. Another area is noise control. Wood is a lighter material, and one of the remedies for controlling noise is mass. And so, again, there are lots of solutions, including some solutions with concrete. For example, concrete topping is generally used in apartments on top of the wood floors to reduce noise. And I will also talk to you about the timber concrete composites floors, and they are also used in different applications. But again, there are solutions with resilient channels and other things. There are solutions that they have been disseminated. The knowledge is there. Another item is building enclosures, especially from an energy efficiency point of view. It's very important to make building enclosures, they are durable, at the same time energy efficient. Because sometimes if you don't do it right, then you can create durability problems, which we had in the past actually. But now we have the know-how, and in our handbooks and guides, we are giving this type of information for building enclosures. So all that information gathered throughout the world, and I call that what we found, actually just came from the research group, is a paradigm shift, working with design and construction community, taking all the research information, packaging them in a multidisciplinary fashion in handbooks and guides. And then early adopters, the people that we work with actually the engineers and the contractors, they are our early adopters. They take what we have and they apply it to buildings. And then at the end, that information coming from handbooks and guides and the buildings, they find their way into the codes. And now in Canada, this year, we are going to have our building code going to come out, 2020 code. And this code is going to allow mass timber construction up to 12 stories. A lot of fire testing is done, fire analysis are done, and other studies are done, and the commission accepted. The proposals came from Canadian Wood Council, and basically we will have 12-story mass timber construction, the gravity system. The lateral system, you can go up to 10-story in low and moderate seismic zones. In high seismic zones, we can go to 6-story. In US, they went even further. in 2021, the US code system will allow mass timber construction up to 18 stories. Again, lateral system is not 18 there, but the gravity system will be 18 stories. So the Brock Commons building that you see here will be an acceptable solution in US next year. Now, I am very pleased to report here that now PFInnovations is making these publications free to download. And you can download the 2019 edition of the Canadian CLT Handbook, which we recently published. This is a 2-volume, over 800 pages. And it has the information on CLT from manufacturing to the construction side. It also has a design example this time, which is an 8-story mass timber building. Not only CLT, it's glulam and mass timber and CLT. And that was a big effort, which I am very pleased to be one of the co-editors of this with my colleague Sylvain Gagnon. And you can also buy a paper copy. I am one of those guys, still would like to flip the pages physically, but that one you have to buy it from Amazon. The other publication that we published first in 2014, but now we are updating that publication. This is the 2021 edition of the technical guide for the design and construction of Tallwood buildings in Canada. This will be available next September. And please take a note and download that one too. It will be free to download again. And this publication tells you all the recent progress that we made in Tallwood buildings. Using our publication, we work with Quebec code people, and they published this mass timber buildings up to 12 stories guide. And this is, you can download this from their website with this link, actually in my presentation, from their website. And again, it's free to download. And that shows actually the Quebec as a province in Canada first allowed 12-story buildings. Now that is making its way into the national code. And lastly, I talked about these timber concrete composite floors. Timber concrete composite, again, a concept came from Europe, and using timber on the bottom, concrete on the top, and some steel connectors connecting the two. And this is a very good system to, for instance, span something like 9-10 meters. And one of my colleagues, Samuel, he actually developed in consultation and cooperation with others, a design guide for timber concrete composite floors. And this is also available for you to download from this website. As conclusion, 21st century is experiencing a renaissance in basically mass timber construction. And a wealth of engineered wood products and connection systems are available. Advanced technologies in fabrication and design are available. There are numerous hybrid possibilities with wood, concrete, and steel. I would like to suggest that having a wood construction strategy is well worth it. And the knowledge is all out there. Thank you very much.
We are very pleased to have your participation. Thank you very much for nice and valuable presentation and contribution to our Congress. Do you have any question you would like to ask to Erol Karacabeyli? Chat box for your questions. I think one question, this one. I think one question you have from Ömer Asim Şişman. What is the advantage, disadvantage of hybrid systems compared to mass timber? When or where do you suggest us to shift from one to another? Thanks a lot first for this beautiful presentation.
Could you repeat the question one more time, please, for me?
What is the disadvantages of hybrid systems compared to mass timber? Oh. When or where do you suggest us to shift from one to another?
Oh, that's a very good question. Thank you. Basically, it all depends on the engineer. And now, for example, when you are having a building where your lateral forces, either from seismic or wind, are extremely high, and it is very tall building, and the geometry doesn't kind of make sense to make a, say, CLT core to work for you as a lateral system. Now, this is the time I think the designer should be open to use a steel or concrete lateral system. And that's one of the examples that I can give for the hybrid. So you kind of make a movement. It's ideal, of course, to use one material because you can reduce the compatibility problems due to shrinkage and etc. But on the other hand, sometimes it just simply makes sense to make a choice. And that is driven by mostly the loads. And so that's one example. It all depends on the building geometry, the loads, and capability of the systems.
Question from Professor Dr. Ümit Cafer Yıldız. Firstly, thank you for your nice presentation. According to you, which kind of wood frame is more suitable for Turkey?
Oh, questions are tough today. Now, all I can say is, I always say, first of all, Turkey had 3 systems itself, and traditional systems, and it's a very good idea to learn from them and maybe come up with its own system. But the thing is, in terms of light frame, now I presented you the light frame system, which is a dominant system in North America. Like concrete buildings, base up to 6-story. That is the dominant system, and some mass timber is getting into that system too. For example, as cores and as some slabs, the floors. So I'm going to answer it this way because it's difficult to say use this or use that. I'm going to answer it what is happening in North America, so that will help maybe to come up with a solution for Turkey. The reason that light frame system is dominant up to 6 stories in Canada and US is because there is infrastructure, materials, design capacity, construction capacity, the codes, everything is in there. And that is kind of making it quite appealing to developers and owners. Mass timber is getting there right now, but it is not a dominant system yet. And there are areas that, you know, after, for instance, after 6, 7 stories, you have to go to mass timber because light frame has its own limitations. So I think in residential buildings, light frame makes a lot of sense to move into. And but on the other hand, mass timber buildings after certain number of stories is the only solution we have in wood. And and hybrid solutions are always should be sought after. But the answer to what is it that you have to do in Turkey is look what you had before. Turkey had 6-story building built in 1896 in Princess Islands. So it had that kind of capacity one time. One has to look at that, look at the historical developments and then what Turkey had before, and then also see what is the best way. And then this is also an urbanization question. Every time I travel in Turkey, I see that everybody is going vertically. It's a I don't know if it is the right thing to do. I am not an expert in that area. So that has to be in the picture as well. But sorry, I cannot say use this or use that, but I'm saying look at all the input from your history and then from outside and then come up with your own solution, basically. That's my answer. Well, I see that I saw the question from Dr. Ali Temiz.
Yeah, I think you saw.
I saw it, and I hope I know him from Vancouver too. He was here many, many years ago. So is Professor Cenk Demirkır. Basically, durability, I don't know if you listened to the presentation yesterday by Dr. Yakup Sandak. It was a beautiful presentation and about estimated service life, and he has simulations for wood appearance, and it was amazing. From my perspective and from my colleagues in durability, it is possible to make buildings very durable. The example that I gave from Vancouver, the building is 115 years old. Believe me, in the first story, and there is a bistro there. When we are eating there, we are actually touching the Douglas fir columns, which was put there some 115 years ago. So durability for that building definitely is there. And it is actually its life. And it will stay there probably another 100 years. But we also had problems in some buildings, in building envelopes, a couple of decades ago, because of the push in energy efficiency. Some envelopes were overlooked, and then we had problems in them. So if the building is done and all the precautions are taken, and you can build wood buildings to last centuries. So the knowledge is there. That's my answer. And what I think is it has to be applied well. It's a natural product, and in certain climates and certain situations, it has to be designed well, taking into account all the possible potential effects.
I think there is no another question. Thank you very much for useful information and valuable presentation again.